Hello children, the continuation of work and energy in that laws of conservation of energy. See, for various energy form interconvertible, can we convert energy from one form to another? We find in nature a number of instances of conversion of energy from one form to another. To know this in a better way, I'll ask some questions to you. How do green plants produce food? Yes, photosynthesis. Where do they get their energy from? And of course, sun. Why does the air move from place to place? Air moves from one place to other due to pressure differences. This pressure difference arises on account of non-uniform heating of ground and seawater by solar radiation. How are fuels such as coal and petroleum formed? They are called fossil fuels, or the products of plants and trees and animals which died millions of years ago. Action of certain bacteria, pressure, and temperature were responsible in converting plants, trees, and animals into coal and petroleum. And what kind of energy conservation sustained the water cycle? Solar energy changes into potential energy of water vapor, which raise in the atmosphere during evaporation. When the clouds bring rain and snow on the mountain mills, their potential energy changes into kinetic energy of water flowing in river and streams. Energy conservation and energy conversions play an important role in nature and help sustain life. Yes, energy transformation. So, the conservation of heat energy into mechanical energy. I'm giving some of the examples. That is, we have discussed various forms of energy which is available, and the energy which are convert from one form to another. And of course, we are seeing some of the examples now, right? So, what is the first I have given? That conversion of energy, heat energy into mechanical energy. In heat energies, in heat engines, heat energy changes into mechanical energy. And in the conservation of electrical energy into light energy, electrical bulb, we know that, fluorescent bulbs. So these and all is electrical energy changes into light energy, right? And the conservation of electrical energy into sound energy, electric bell, stereo, and loudspeakers, this and all we can say that. So now we have just discussed about the various examples of the transformation of energy from one form to another form. In such all the cases, energy in one form disappears and reappears in another form, right? And we can say the total energy of a system during and after the process is get transferred, right? So the total energy which gets remains unchanged. So this only we can call it as this law, is the law of conservation of energy. So according to this law, we can say the energy can only be converted from one form to another. It can neither be created or destroyed, right? So the total energy before and after transformation, the remains the same. The law of conservation of energy is valid in all situations and for all kind of transformations we can say. Now we can consider an example to know in a better way. See, let an object of mass m and be made to fall free from a height h we can take. At the start, the case 1 at the start, the potential energy is what? Potential energy is mgh. And the kinetic energy is 0. Why the kinetic energy is 0? It is 0 because of the velocity is 0. So the total energy of the body, we can say that mgh. In second case, we can take it falls. If as it falls, its potential energy will change into kinetic energy. If we suppose we have taken as the velocity of the object, the kinetic energy is half mv square. As the fall of objects continues, the potential energy obviously what will happen? Yes, it will get decreases, while the kinetic energy would increase at the time of as it falls, during the fall. When the object is about to reach the ground now, that time h which is equal to 0 and v will be the highest one. So therefore the kinetic energy would be the largest and we can say the potential energy is least one. So however the sum of potential energy and the kinetic energy of the object would be the same at all the points. So we can say the potential energy and the kinetic energy which is equal to constant, or we can say that mgh, that potential energy we are representing here mgh plus kinetic energy half mv square which is equal to constant. So the sum of kinetic energy and potential energy of an object is its total mechanical energy. Now we can see some activity. I have some question. A body of mass 2 kg is projected vertically upwards with a speed of 3 meter per second. What will be the maximum gravitational potential energy of the body? Yes, the gravitational potential energy which is equal to kinetic energy. So that half mv square is the formula, that is equal to half the mass which is equal to 2 kilogram they have given 2 and the speed that is velocity 3 square. So after we calculated, simplified, we got 9 joule. Have you got it? Then at sea level, a nitrogen molecule in air has an average translational kinetic energy of 6.2 into 10 power minus 21 joule. Its mass is 4.7 into 10 power minus 26 kilogram. If the molecule shoots up straight without resistance, it will raise to a height of what? The answer is kinetic energy of the molecule is converted into its potential energy, right? So mgh which is equal to what? 6.2 into 10 power minus 21 joule. So we want to know what is its raise to its height, right? H which is equal to 6.2 into 10 power minus 21 whole divided by 4.7 into 10 power minus 26 into 9.8 G. Okay. So if I simplify this, you will get 13.5 km, that is kilometer, right? Thank you, children.